All right, still on page 291, we're just going down to properties of multiplication. So the commutative property, again, just like the commutative property of addition, deals with the order of the factors. And same idea, when you're multiplying, the order of the numbers does not matter. Okay, so again, these properties you're learning about are only true of addition and multiplication. You can't apply these to subtraction. Okay, you can't apply these to division because in both of those the order matters. Okay, the associative property, again, just like in addition, the associative property of multiplication says the grouping doesn't matter. If we have all multiplication, where we put the parentheses does not matter. We can group them however we want. Okay. In fact, we could even change the order and group them differently, and it would still not change it. So, for example, I could change the order to 11 times E times 3, and I could put the parentheses around the 11 and the E if I wanted to. So, the grouping does not matter with multiplication, and the order does not matter when you're dealing with multiplication. Now, the identity property is a little bit different with multiplication, because if you multiply anything by 0, it just equals 0. Whereas in addition, if you add 0 to anything, you don't get 0, you get the number you started with. So the identity property of multiplication says if you multiply anything by 1, then you get the number itself. So 1 times f is f. 1 times 8 is 8. 1 times 10 is 10. 1 times c is c. But again, the identity property of addition, you have to use 0 plus f to get f. But with multiplication, it's 1 times whatever you have, and you get the number itself. Okay. All right, let's unlock this problem. Nelson ran 2 miles, 3 laps, and 5 miles. The expression 2 plus 3L plus 5 represents the total distance in miles Nelson ran, where L is the length in miles of 1 lap. Write an equivalent expression with only 2 terms. Okay, so we're kind of taking our knowing what we know about the rules of addition and multiplication, that when we're adding, we can change the order of things, we can change the grouping, coupled with the lesson that we learned yesterday about combining like terms. Okay, so the like terms in this case, so we have, here are our terms. 2 is 1 term, it's separated by an addition sign. 3L is 1 term, and 5 is another term. So L is only attached to this term, so it doesn't have any other like terms. But these 2 terms, 2 and 5, don't have anything attached to them, and they have no exponent, so we can combine those 2. So the like terms are 2 and 5. Okay. Now, use the blank property to reorder the terms. Well, if I'm reordering, my order property is the commutative property. Use the blank property to regroup. Well, my grouping property is the associative property. Okay, so I'm going to regroup first. So I'm going to put the 2 next to the 5. Then I'm going to regroup them with 2 plus 5 in parentheses, so I can combine those 2 terms and make that 7. So an equivalent expression for the total distance would be 3L plus 7. So I just combined my two like terms. That's essentially what you're doing. Essentially, we're doing the same thing we did yesterday, where we're combining like terms. Okay. All right, thanks for watching. I'll see you on the next one.